Hello, today we are doing 5-3, and I'm going to start with a little review of the graphs of polynomial functions. So if you will recall, when we graph a square, it looks like a parabola. And I tried to get you guys to remember how to use a t-chart. So if we plugged in 0, then for x, then y is going to be 0. If we plug in 1, y will be 1. If we plug in 2, y is 4. And 3, y is 9. And so with a parabola, it looks like a race shape, a bowl shape. And it looks just like this. And if you will also recall, there is a limit on the range because it does have that minimum value down there. So our domain is negative infinity to positive infinity, but our range has that limit where it is, and this is supposed to be a bracket, where it can't go any lower than that minimum. Now with a cubic function, and this is true for any even-powered function, recall that as well. So as long as the exponent isn't even, you have, the domain is infinite, but the range is both positive and negative. With a cubic, you get, again, your values again, and this time, when you plug in a negative, you get a negative out. And it looks something like this. And it gets steeper and steeper the further up and down you go. But the domain on these is negative infinity to infinity. And the range is also negative infinity to infinity. So now we're going to kind of take what we know about graphing and polynomial functions and apply it to our rational functions. Now don't stress out. This is not a huge part of what we're going to be doing this unit, but you do need to kind of get the concept, and you need to make sure that you do your nice little t-chart. So this, your example 1, asks you for a domain and range to start out. So when you are taking a root and your index is even, remember, if there's nothing there, we assume that it's that's not going to work. We assume that that index is a 2. So this is an even index. We need to make sure that whatever's underneath has to be positive. So I'm going to make my 3x greater than or equal to 0. And it's not that it has to be positive, but it has to be non-negative. So we divide by 3, and x has to be greater than or equal to 0, which means that our domain starts at 0, and it's going to go to infinity. And then if we plug in that minimum value for our domain, we get the square root of 0, which is also just 0. So our range is also 0 to infinity. Now, knowing all of that, I want to kind of, before we actually graph A, I'm going to graph our parent function. And our parent function for a square root is just y equals square root x. And y equals square root x has this same domain and range as this function. So these don't change as long as there's nothing changing underneath. Now, y equals the square root of x. So when you think about the square root of x, you need x to be nice perfect squares so you can graph your y's. So 0 is 0 squared, 1 squared is 1, 2 squared is 4, 3 squared is 9. So you're thinking of this backwards. We call these inverse functions so that your x and your y's are inverse, or so that these functions are inverse. So y equals square root of x and y equals x squared are inverses of one another. So if I put in y equals square root of x, it's going to look like this. 1, 4, 2, over to 16. I'm going to get 4, 9, 3. And as you draw that, 25 is going to be 5. As you draw that, you'll see that it looks like just half a parabola. So it's just a half parabola. And we stick that in there, and that's it. So that's what y equals square root of x. So now I'm going to change colors. We're going to do this actual problem, which is y equals the square root of 3x. So with this one, we're going to start out just like we did last time with our x and y chart. And I'm going to do the same thing with my y's. I'm actually going to plug those in first and solve for x so that I know where to put them. So if I plug in 0 for y, 0 equals the square root of 3x, and I square both sides and I divide by 3, x is still going to be right there at 0. But when I plug in 1, I'm going to square both sides. I get 1 equals 3x, and then divide by 3. X is 1/3, where y is 1. So x is over here like this, like not even at 1. Then if I plug in 2, so 2 equals the square root of 3x, and I square, I get 4 equals 3x. So x in this case is going to be 4/3, which is a little greater than 1. So at 2, that y equals 2, x is going to be a little bit bigger than 1. So you'll notice this 3 is kind of stretching this graph. If I plug in 3 for y, then 3 times 3 is, or 3 squared, 3 squared is 9. And then we divide by 3. So x then is 3. So we get 3, 3. And then I plug in 4. I think I can write it over here. Nope, let me write it over there. So 4 equals square root 3x. 16 equals 3x. And x equals 16 over 3, which is about 5 1/3 if we put that in the calculator. So at 4, we put 5 1/3. And so then from there, you can just kind of draw your graph. Okay? Now let's look at B. So B, is a cube root function. And again, I want to start by looking at our parent function. So our parent function is just y equals the cube root of x. So to do that, we need to think of perfect cubes. So 0 cubed is 1, 1 cubed is, or 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and we're going to pause there and start with this one in a new video.